Hello everyone. In today class, we will discuss another topic of matrix chapter. Okay. Now, the first chapter is first topic is rank of a matrix. So, today our first topic is rank of a matrix. That is a very important topic for your examination point of view. That was rank of a matrix. Okay. What is a rank of a matrix? A matrix a non-zero number of row is said to be rank of a matrix A if there exists at least a minor of order R, and second one, every minor of higher order every order of higher order then R is zero. If a non-zero R, if a non-zero number R is said to be a rank of matrix if there exists of at least a minor of order R, and second one is every minor of higher order then R is zero. Generally, this is a very easy method to prove to find the rank of a matrix. Okay, so firstly, definition is not so much important. I will tell you the method to find the rank of a matrix. Okay, the firstly you write the definition, then I will give some question. I will solve some question for you how you can find the rank of a matrix. Okay, the rank of a matrix is generally denoted by the rank of a matrix is denoted by row A. Okay, now there are two methods to find the matrix. First is rank of a matrix. First is minor method. That was known as determinant method. Determinant method. Second one is your Aclean form, and also there are two more form, but they are not in your syllabus. That are in your higher classes. That is canonical form, or second one is using row and column transformation. That are not so much important. You have to try only one method to find the rank of a matrix. Now firstly, what is the rank? Generally a rank, you can see here, suppose 1 0 0 0 1 0 0 0 0. So if you take the determinant, so you will get the value of will equal to 0. Okay, but if you take any 2 by 2 order matrix here, so you will get the value 1. So the number of determinant of order which you get the value does not equal to 0, that are the rank of the matrix. So in that case, the rank of the matrix will be 2. So generally, the identity matrix is of make one point here. The order of an identity matrix is a rank of identity matrix. Okay, that was important theorem that if you have identity matrix of 2 by 2, that means 1 0 0 1, then the rank of the matrix I2 will be 2. And if you have matrix I3 1 0 0 or 0 1 0 or 0 0 1, then you have rank of I3 will be 3. So in identity matrix, the order of an identity matrix is the rank of that matrix. Now next thing is how to find the rank of a matrix by determinant method. Now first the question one is A is equal to find the rank of A. Find the rank of A. So if A equal to 202 134 minus 1 minus 2 minus 3. Now you can find, firstly you have to find the determinant of that one. So the determinant of mod A is generally the minor of A of 3 by 3. So 202 134 minus 1 minus 2 minus 3. So 2 bracket 3 into minus 3 will be minus 9. Uh, how we can solve this question? So firstly you have to take 2. Okay, that one. Now this row and this column will be hide. So 3 into minus 3 will be minus 9 minus time of 4 into minus 2, which will become minus of 8. Now next, which is next number to 2, just a minute, minus 9 minus 8. Then minus 1, 0 minus 3 is minus 3 and minus 2 into minus 2 is minus 4. Now take second one, take the sign minus of the second one and skip the second row and second column, corresponding rows and corresponding column. Now multiply 0 into minus 3 and 2 into minus 2 minus 4, minus times of minus 4. Now next one is plus 1 minus 4. Next one is plus, sorry, minus 1. Now cross multiply 0 into 4 will become 0, 3 into 2 will become minus 6. Now 2 into minus 9 of minus 8, that must become minus 8 now. So 2 into minus 9 plus 8 minus 1 minus 3 plus 4 minus 1 into minus 6. So 2 into minus 1 will become minus 2 and minus 1 into minus 3 plus 4 will become minus 1. Just a minute. Generally 0 into 3 is 0. That was 0. 0 into minus 4 will become plus 4. So 0 minus minus of 4, 0 into plus 4 is minus 4 and minus 6. Minus minus will become plus 6. So is equal to 0. So determinant of A equal to 0. That means it is not possible that rank of a matrix will be 3. Okay. Now we can check any 2 by 2 minor. Now I am taking any 2 by 2 minor. Firstly, I am taking 2013. Okay. That I am taking 2 points of that matrix 2103. Now if I multiply 2 3 just 6 and minus 0. So we will get 6. So rank of a matrix of 2 by 2 does not equal to 0. So rank of a matrix is 2. Because we get a 2 by 2 minor which is not equal to 0. So here the rank of the matrix will be 2. Okay, clear? Now I'm solving one more question for you. Second question is find the rank of a matrix A. Find the rank of a matrix A. A is equal to minus 1, minus 2, minus 1, minus 2, 4, 2, 3, minus 1, 7. Now firstly check 3 by 3 minor. So mod equal to minus 1, minus 2, minus 1, minus 2, 4, 2, 3, minus 1, 7. Now check one by one. So minus 1 times of 4 into 7, 28, and plus minus minus will become plus 2. Minus minus will become plus 2. Now minus 2 into 7, minus 14, minus minus of 1 will become minus 1. Okay, plus 3. So minus 2 into 2, minus 4, plus 4. So that term will become 0. So 28 plus 2 will become minus 30, and 2 into minus 15 will become minus 30, and plus 3 into 0 will become 0. So minus 60. So here we did not get the value 0. So rank of a matrix A will be here 3, because in this question we get the highest minor of matrix which does not equal to 0 will be 3. Now next question is to solve by Euclidean form. That was your first form, which is known as the determinant form. Now second one is your Euclidean form. Euclidean form is, suppose you have a matrix A is equal to 1 A B 0 0 C D 1 and 1 A B 0 and 0 C D 1. Euclidean form. Euclidean form. So generally, what this form tell us, this form tell us that after applying the row and column transformation, so you have to find the number of rows that are that contain element. Okay, so that will be the rank of that matrix. Suppose that was the question, 1 A B 0 0 CD1, 1 A B 0 and 0 CD1. If I apply R3, R3 means that row tends to R3 minus R1, and if I apply R4, R4 tends to R4 minus R2. That means this row will be minus by this row, and this row will be minus by this row. So you will get the value of A is equal to 1 A B 0 0 C D 1 0 0 0 0 0 0 0 0. So you will get two rows which contain an element. So here the rank of a matrix will be 2. Okay, so you can try any of the method, either by Euclidean form or either by canonical form, to solve the question. Okay, so one more question I have to solve by Euclidean form. The question is 1 2 1 2 4 2 3 6 2 1 2 2. Okay, I am solving it by Euclidean form. So how I can solve by Euclidean form? Uh, you can also solve by determinant form. So firstly, I will solve by both the method. Okay, for you. For determinant method, you have to take the determinant. Determinant is generally of square matrix. So, but it is the order of 3 cross 4. So here 4 will not be the rank of the matrix, because for 4 we have to take the matrix of 4 by 4. So we can take any matrix of 3 by 3. Okay, then we can check the rank of a matrix. How we can find how either that it will become 0 or not. You can take any row column. Either you can take that one, 1 2 1 2 4 2 3 6 2, or either you can take 2 4 2 1 2 2 2. Okay, then you can check that 3 by 3 matrix is the you find you will get the value 0 or not. If you will not get the value 0, then that will be the rank of a matrix. But here I can solve it by the Euclidean form. So how I can solve by the Euclidean form? That was R2. So if I apply R2 tends to R2 minus 2R1. So what I get, R2 tends to 2R1 means 1, and 2 minus of minus 2. 2 minus of 2 into 1 is 0. 1 2 3 1 1 2 2 2. Just a minute. R2 tends to 2 times of R1. So 2 minus 2 into 1, 4 minus 2 into of 2, 6 minus 2 into of 3, and 2 into, um, sorry, 2 minus 2 into of 1. So you will get the value 1, 2, 3, 1, 0, 0, 0, 0, 1, 2, 2, 2. Now transform R3 to R2. So R3 tends to R2. So you will get 1, 2, 3, 1, 1, 2, 2, 2, 0, 0, 0, 0. So you will get here are two rows, okay, which are not zero. So rank of a matrix is here. So generally that are the question, that how that is the are the method. So how you can solve the questions. Okay. Now our next topic is coming to our next part. So that was your uh, minor and cofactor. Minor and cofactor. Okay. So what is a minor? Suppose that was your matrix A, B, C, D, E, F, G, H, I. So the element are here A11, A12, A13, A14. Okay. So firstly, if I say what is the of minor of A11? A11 means the element here, first row, first column. First row, second column, first row, third column, second row, first column, second row, second column, second row, third column, third row, first column, third row, second column, third row, third column. So minor of A11, that means that's minor. So what is the minor of that one? So you have to skip that row and that column. First row skip, first row column will be skipped. So what will you get the value? E into I minus H into F. So what is the minor of A11? Determinant of E into F, H into I. So you will get by cross multiply E into I minus H into F. Okay, minus H into F. Now second one, the minor of A12. Minor of A12. A12 means first row and second column. You have to skip first row and second column. So you will get the value DI and GF. So you will get the value of determinant DI and GF. DF, GI. So on solving, you will get DI minus GF. Now third is minor of A13. Minor of A13. A13 means first row, third column. You have to skip first row and third column. So you will get the determinant DH and EG. Okay. A13 will be D, E, G, H. So you will get value DH minus EG. So that was your minor of A11. Now minor of A21. Minor of A21. So how you can get the minor of A21? So A21 means second row, first column. That was element, second row and first column. So you have to skip second row and first column. Now you will get the four values B, C, H, I. So what is the B, C, H, I? Just a minute. B, C, H, I. So you will get value Bi minus C, H. Now next is minor of A22. Minor of A22. A22 means second row and second column. So that was your of second row and second column. So you will get value AI and CG. A12 is ACGI. So you will get value AI minus CG. Now minor of A13. Minor of A23. A23 means you have to skip second row, third column. Second row, third column. That was the element you have to skip. So AH and BG. GH. On cross multiplying, you will get AH minus BG. So that was the value of minor of A23. Now the minor of A31. Minor of A31. A31 means, and last one is minor of A32. Minor of A33. Minor of A33. So the minor of A31 is you have to skip third row and first column. Third row and first column. So you will get value B, C, E, F. B, C, E, F. So you will get BF minus CE. Now A32 means you have to skip third row and second column. So third row and second column. So you will get B, C, D, F. So B, C, D, F. So you will get BF minus DC. Minor of A33 means you have to skip third row, third column. So A, B, D, E. A, B, D, E. So you will get A, E minus B, D. So that was the value of your minor. Minor of A11, minor of A12, minor of A13, minor of A21, minor of A22, minor of A23, minor of A31, minor of A32, and minor of A33. And now what is the cofactor? Cofactor is multiply with that element. Okay. So generally cofactor, next term is your cofactor. So cofactor is defined as Cij is equal to minus 1 of I plus j into Mij. Minus 1 of I plus j into Mij. So that was your cofactor. Suppose you have value of M11. So I is 1 and j is 1. So you have to put minus 1 upon 1 plus 1 Mij. So 1 plus 1 is square. So minus 1 ka square is 1. So Mij. Now second one is M12. So minus 1 to the power 1 plus 2 and Mij. 1 plus 2 is 3. So minus 1 to the power 3 is minus Mij. So M12 means. And M13 means minus of 1 to the power 1 plus 3 into M13. 1 plus 3 is 4 and minus 1 to the power 4 is 4. So M13. Now similarly, the value of M21. M21 is minus 1 to the power 2 plus 1 M1 M21. So 2 plus 1 is 3. So minus 1 to the power 3 is minus 1. So minus M21. M22. M22 means minus 1 to the power 2 plus 2. 2 plus 2 is even number. So minus 1 plus 2 is M22. And M23 is minus 1 to the power 2 plus 3 into, sorry, M23. So you will get minus of M23. Generally, you can denote them by C21, C22, C23. Okay. That was easy for you to learn the cofactor and matrix. So you can denote it by C11. C11 generally in the book that are also represented by M. Okay. C12, C13. So C21, C22 and C23. Similarly, you can find the value of C31, C32, C33. Now, what is the determinant? Determinant is, suppose you have the value A. So the value of determinant is A11 into C11 plus A12 into C12 plus A13 into C13. Suppose you have A, B, C, D, E, F, G, H, I. So what is the value of that determinant? That determinant is you multiply corresponding element with their cofactor and corresponding element with their cofactor. So you will get that value of determinant. Either you can take by row or you can take by column. So you can take it by column also. A11, C11 plus A12, sorry, A21, C21 plus A31, C31. So you will get the same value. Okay. So determinant means multiply element with their cofactor. Okay. Now I'm giving you question. Second is suppose A is equal to 1, 2, minus 1, 3, 4, 0, 2, minus 2, 1. So what is the value of determinant? Firstly, I am taking by row. So 1 into of 4 into minus 2, 4 minus 2, 0, 1. Now take the cofactor here. So minus, what is the position of that element? First row, second column. So minus 1 to the power 1 plus 2 means odd number. So that's why minus sign will become minus 2. Now skip that row and that column. So 3 into 1, 3, 0, 2, 1. Last one is minus 1 and position of minus 1 is A13. So 3 plus 1 is 4, minus 1 to the power 4 is plus. Okay, that's why the plus sign came, but here the minus sign will be there. So that's why I will take the minus sign. Okay, so 3, 4, 2, minus 2. Now I'm doing the cross multiply. You will get 1 into 4 and minus of 0. Minus 2 into 3 into 3, minus of 0. So minus 1, 3 into minus 2, minus 6 of minus 8. So 1 into 4 is 4, minus 6, and minus 6 minus 8 is 14 plus 14. So 14 of 4, 18, minus 6 is 12. So that's why you will get the value of determinant A as 12. Okay, that was your matrix. Now second is your adjoint of A. So adjoint A is generally a transpose of cofactor of a matrix. Okay, so adjoint A is a transpose of cofactor of matrix. So what is the adjoint A? Transpose of cofactor of matrix. So firstly, suppose you have A is equal to 2 minus 1, 3, and you can take any value 5. So here, what is the value of C11? C11 means that one. So minus 1 to the power 1 plus 1 is 1 plus 1, and then you have to skip that row, that column. You will get the value 5. So you will get 5. C12 means minus 1 to the power 1 plus 1. 1 plus 1 is, uh, sorry, 1 plus 2 is odd. So minus 1 to the power 3 is minus 3. And which was the element is 3. So minus of 3. C to 1. That element is C to 1. So minus 1 to the power 2 plus 1. And here is minus 1. So minus minus of 1 is plus 1. C to 2 means minus 1 to the power 2 plus 2 and 2 here. So minus 1 to the power 4 is even. So you will get 2. Now if you take the matrix of cofactors, so C11, C12, C21, C22. So that was matrix of C cofactors. So C11 is 5, C12 is minus 3, C21 is 1, and C22 is 2. Now, adjoint is a cofactor of that matrix. Adjoint is a cofactor of that matrix. The transpose of cofactor of that matrix. So 5, 1 minus 3, 2 will be the cofactor of that matrix. Similarly, you can find the adjoint of 3 by 3 matrix. Suppose a matrix will be there. Find adjoint of A. A is equal to minus 1, 0, 1, 2, 0. Just a minute, 2, 2, 0, 2, 1, 0, minus 2, 0, 1. Now, firstly, find the C11. So, C11 means minus 1 to the power 1 plus 1. Skip that row and that column, first row and first column. So, you will get determinant 1, 0, 0, 1. So, on solving, you will get 1. C12 means minus 1 to the power 1 plus 2 and 2, 0, minus 2, 1. On solving, you will get minus 1 plus 2 is 3. So, minus 1 to the power 3 is minus 1. So, minus 2. C13 means minus 1 to the power 1 plus 3 and skip that row and that column. So you will get 2, 1 minus 2, 0. On solving, you will get 2 into 0, 0 and minus minus of 2 is plus 2. Okay. C21 is minus 1 to the power 2 plus 1 and skip that row and that column. So you will get 0, 1, 0, 1. On solving, you will get 0 into 1 is 0 into 1 is 0. Now C22 is minus 1 to the power 2 plus 2. So you will get minus 1, 1, minus 2, 1. So on solving, you will get minus 1 plus 2. So minus 1 plus 2 is 1. So C23 means minus 1 to the power 2 plus 3. So you will get minus 1, 0, minus 2, 0. So on solving, minus 1 into 0, minus 2 into 0 is 0. So that's why you will get value 0. Now C31. C31 is minus 1 to the power 3 plus 1 and you will get value 0, 1, 1, 0. On solving, you will get 0. And C32 is minus 1 to the power 3 plus 2 minus 1, 1, 2, 0. On solving, you will get 3 plus 2 is 5. So minus 1 to the power 5 is minus 5. And here minus 1 into 0 is 0 minus 2. So you will get 2. C33 is minus 1 to the power 3 plus 3. So minus 1, 0, 2, 1. So you will get minus 1 here. So you will get the transpose, sorry, cofactor matrix as C11, 1, 2, 1, 3 as 1 minus 2, 2, 1 minus 2, 2, 0, 1, 0, 0, 1, 0, and next is 0, 2, minus 1, 0, 2, minus 1. So adjoint A is a transpose of that cofactor matrix. So you will get 1, 0, 0, minus 2, 1, 2, and 2 0 minus 1 will be the value of adjoint A. So that was your value of adjoint. Now next topic is your, just a minute. Properties of adjoint of a matrix. Properties of adjoint of a matrix. Now the first property is A into adjoint A, or you can multiply adjoint A into A. You will always get mod A into I. Mod A means determinant A into I. Second property is the determinant of adjoint A is always equal to mod A to the power n minus 1, where n is the order of A, where n is the order of E. Third property is adjoint into adjoint A is equal to mod A to the power n minus 2 into A. Fourth one is adjoint A into B is equal to adjoint B into adjoint A. Fifth property is adjoint A whole transpose is equal to adjoint of A transpose. Sixth property is adjoint of Ka is equal to K to the power n minus 1 into adjoint A. So that was the property of adjoint. A into adjoint A or adjoint A into A is always determinant A into I, or the determinant of adjoint A is always determinant A to the power n minus 1. And next, adjoint of adjoint A is determinant A to the power n minus 2 into A. And adjoint A into B is always adjoint B into adjoint A. So that are the some important results of the properties of adjoint. Now I'm taking some example or previous year questions of your chapter. First question is find the rank of a matrix. Find the rank of a matrix. One two zero 431 minus 102. Okay, so you have to find the rank of that matrix. How we can find? Firstly, check by determinant method. So A is equal to 1, 1 2 0 431 minus 102. So check 1 times of 3012 minus 4 times of 2002. Next, minus 1 times of 2301. So 3 to just 6, 1 into 6 minus 0, minus 4, 2 into 2, 4 minus 0, minus 1 into 2 minus 0. So 1 into 6 is 6, minus 4 into 4 is 16, and minus 2. So minus 18, 6 minus 18 is minus 12. So which does not equal to 0. So that means the rank of a matrix A is 3, because we does not get 3 by 3 matrix as the value of determinant as 0. Now the next question is, find the rank of a matrix. Find the rank of a matrix. The rank of a matrix 1 to 0, 2, 3, 1, and 3, 4, 2. Now first to find the value of determinant. So 1, 2, 0, 2, 3, 1, 3, 4, 2. So 1 times of 3, 1, 4, 2 minus 2 times of 2, 0, 4, 2 plus 3 times of 2, 3, 0, 1. So on solving, you will get 1 into 3 to the 6 minus 4 minus 2 into 2 to the 4 minus 0 plus 3 into 2 minus 0. So 6 minus 4 is 2. So 1 into 2 is 2. Minus 2 into 4 is 8. Plus 3 into 2 is 6. So 6 plus 2 minus 8 will became 0. So rank of a matrix does not equal to 3. So then we have to check it by 2 by 2 matrix. So then check it by 2 by 2 matrix. You will get, take any matrix. So I am taking 1, 2 and 2, 3. So next is A dash 1, 2, 2, 3. So you will get 3 minus 4, which is equal to minus 1, does not equal to 0. So rank of a matrix A is 2, because we have got 2 by 2 minor, which does not equal to 0. Now next is, what part is also there. Next is, find the rank of a matrix. Find the rank of the following matrix. Rank of the following matrix, and the matrix is given as 1, 1, 1, 1, 1, 1, 1, 1, 1. So first thing, I can find this by Euclidean form. Okay, because I am seeing that rows and column are equal, so I can find it by Euclidean form. So A is equal to uh, 1, 1, 1, 1, 1, 1, 1, 1, 1. Now I'm applying R2 tends to R2 minus R1 and R3 tends to R3 minus R1. So on applying that rows and column transformation, so I will get A is equal to 1, 1, 1, 0, 0, 0, 0, 0, 0. So I will find only one row which is does not equal to 0. So here rank of matrix A is 1. Just a minute. Now next question is given that if theta minus phi, theta minus phi is equal to pi by 2, then show that then show that cos square theta, cos theta sin theta, and cos theta sin theta, sin square theta into cos square phi, cos phi, cos theta, sin phi, and cos phi, sin phi, and sin square phi is equal to 0. Just a minute. Question is theta or phi there. Cos phi, sin phi. There. Cos phi, sin phi. So that was your important question. We know that theta minus pi equal to pi by 2. So theta equal to pi by 2 plus phi. Okay. So on applying theta equal to pi by 2 plus phi. On applying is it, you will get cos square theta, cos theta, sin theta, cos square theta, cos theta, sin theta, cos theta, sin theta, sin square theta into cos square phi, cos phi, sin phi, cos phi, sin phi, sin square phi. I am taking LHS. Firstly, I am taking LHS. Taking LHS. Now apply theta equal to pi by 2 plus phi. So cos square pi by 2 plus phi, and here also cos pi by 2 plus phi, sin pi by 2 plus phi, and in by also cos pi by 2 plus phi, sin pi by 2 plus phi, and sin square pi by 2 plus phi. And here cos square phi, cos phi, sin phi, cos phi sin phi sin square phi. Now, generally, we know that cos 90 plus theta is minus sin theta. Cos pi by 2 plus phi is minus of sin phi because it's come in the second quadrant and 90 into odd multiple change to sine. So, cos, next is sin pi by 2 plus phi. Sin pi by 2 plus phi. Sin 90 plus theta is also cos theta, cos phi. Okay, because sine 90 change to cos, and in second quadrant, sine is positive. So on solving, you will get sine square phi minus cos phi sine phi minus cos phi sine phi and cos square phi. Here you will get cos square phi, cos phi, sine phi, and cos phi, sine phi, sine square phi. Now multiply row by column. Okay, 2 by 2 matrix, you will find the value of 2 by 2 matrix. Now firstly, multiply sine square phi minus cos phi sine phi with cos square phi cos phi sine phi. So you will get sine square phi cos square phi sine square phi cos square phi minus cos phi sine phi into cos phi sine phi cos square phi sine square phi. That means sine square phi and cos square phi. Now this element is A12. Multiply first row with second column. So sine square phi into cos phi sine phi. That means cos phi sine q phi minus cos phi sine q phi. Cos phi sine q phi minus cos phi sine q phi. Now that what sec A21 means second row multiply by first column. So minus cos phi sine phi with multiply with cos square phi. That means minus cos cube sine phi and cos square phi multiply with cos phi sine phi. That means cos cube phi. So minus cos cube phi sine phi plus sine phi cos cube phi. And A22 means second row multiply by second column. So minus cos square phi sine square phi plus sine square phi cos square phi. So minus cos square phi sine square phi plus sine square phi cos square phi. So on solving, you will get 0, 0, 0, 0 as 0 matrix, hence which is equal to RHS. Okay, that was your proof. Now the next question is, next question is, if A equal to 3003, find A to the power q. Okay, find EQ. I'm also defining this question earlier, same by 3 by 3 matrix. If A is A00A, now, so A to the power n equal to, if there are same element present in the diagonal, so their value will be A and 0, 0 to the power A n. Okay. So here a equal to 0 3, sorry, 3003. So a cube equal to 3 to the power 3, 3 to the power 3. So 3 to the power 3 is 27,0,027 will be the value. Okay. Now the next question is inverse of A. Now next topic is your inverse of A. How do you define the inverse of A? I have defined A into adjoint A is determinant of A into I. Now, if that A coming downward and that A comes in denominator of I, so adjoint A upon mod A equal to I by A. If that A coming upward, so A inverse into I is equal to adjoint A upon mod A. So the value of A inverse is A into adjoint A. A inverse is equal to adjoint A upon mod A. So question is find the inverse of a matrix. Find the inverse of a matrix. Inverse of a matrix 1 3 2 minus 5. Now first we find the adjoint of that matrix. So for adjoint, you have to find the value of cofactor. So C11 is minus 1 to the power 1 plus 1 into minus 5. So 1 plus 1 is 2. So minus 1 to the power 2 is 1 and then minus 5 here. So C12 is minus 1 to the power 1 plus 2 into 3. So you will get minus 3. C21 you will get minus 1 to the power 2 plus 1 into 2. Minus of 2 and C22 will get minus 1 to the power 2 plus 2 of 1. So which is equal to 1. So the matrix of cofactor is minus 5, minus 3, minus 2 and 1. The adjoint of matrix is co-transpose of cofactor of that matrix. That was minus 5, minus 2, minus 3, 1. Okay. That was the adjoint of a matrix. And now find the determinant of matrix. So A equal to 1, 3, 1, 3, 2 minus 5. So the determinant of matrix is minus 5 into minus 6, which is equal to minus 11. Okay. So A inverse is 1 upon mod A adjoint A. So the value of adjoint A is minus 5 minus 2 minus 3 1. So minus 5 minus 2 minus 3 1 and the value of determinant is 1 upon minus 11. On multiplying inside, you will get 1 upon 11, 5, 3, 2, minus 1. That was your inverse. So, student, that are some question and some concept of your chapter. And if the some concept, other concept are left, so I will cover in the next video. Okay. So that's all for today. In the next class, I will discuss about another question and some important topic which have been left of that chapter, so you can revise that chapter. And if you feel doubt in any question, then you can send the question to madam and sir, so they will forward me and I can solve that question in video. So in video. Okay. So that's all for today. If you feel any doubt in the question, so tell the sir and send the question to the sir and madam. Okay. That's all for today. Thank you everyone.